So today we're going to look at summation notation and partial sums. What these are is a way to combine all the terms of your sequence together and add them up and find a total number. Okay, so there's two ways to do this. We're going to show you both. First is summation notation. Okay, so this is what summation notation looks like. We're going to tell you all the different pieces that make up it and then show you how it works. Okay, the first piece is that big black letter. It's a Greek letter called sigma. Sigma is signifying to you, when it's written down, that you're going to take all the terms of your sequence and add them all together to make one big sum, which is why it's called summation notation. Notice the sum in summation. Okay. The next part is the blue part on the bottom. This is your first input for n. You'll notice there's an n in green. This is an expression. We're going to get to that in just a second. We're going to put values in for n, starting with 1 because it tells us that on the bottom. And going to, we get to the last input, which is at the top. This is the last input you're going to have for n. So if you start at 1, then you're going to go to 2, then 3, and then 4, and then stop. Okay? And you're putting these values into the n value in your expression, which is right there in green. And our expression in this case for this problem is 3 times n. Okay? So you'll have 4 different terms, starting with 1, and then going to 4, that are going to be put in for the n value. Find the terms of the sequence and add the 4 terms of the sequence together. This is what it looks like. So if you're starting at 1, you put 3 times 1, then you go to 2, put 3 times 2, go to 3, 3 times 3, go to 4, and then 4 times 3. And then you are stopping because your last input was 4. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. When you combine all those terms, 3, 6, 9, and 12, and add them all together, you get your sum, which would be 30. And this is the sum of that sequence. Let's look at another example. So we have our summation notation. This time our expression is 2 to the n. We're going to start at the first input, which is 1. All right, so you go 2 to the first, and you're going to go all the way till you hit number 5, putting 5 in for n, so it's 2 to the first, then 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth. So now there's 5 different terms starting at 1, ending at 5. We find out what those values are. 2 to the first is 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, and 2 to the fifth is 32. Get all those values together and add them up. 2, 4, 8, 16, and 32 gives you 62 as a total sum of your sequence. Okay. Now there's one more question on there. Please try that one out. See what you come up with, and then we'll move on. All right. So you try that one out. We're ready to go for partial sums. Okay. Partial sums is a little bit different than summation notation. It does the same thing, but in a different way. So we're still finding the sum of a sequence. So taking the individual pieces of or terms of a sequence, adding them together. The difference is this. For some partial sums, the summation notation, putting it in there and figuring out the expression, taking all the separate numbers, adding them together, would take forever. Okay. Let's say your initial value was 1, and you wanted to go to a final value of, let's say, 100. Would you want to find 100 terms, take those 100 terms, and add them all together? That would be awful. So some formulas were developed so you could figure out what those sums are for both arithmetic and geometric sequences without having to do all the summation notation. Okay, now there's a caveat to that. The formulas are a little bit more complicated, obviously, because they are formulas for this idea. So if you're doing a small sequence, let's say, 3, 4, 5, 6 numbers of terms, then summation notation would work fine. Partial sums might be a little bit overkill. But if you're doing something with a lot of terms in it, you want to not do summation notation and do the partial sums formulas. Okay, so let's look at the formulas themselves. There are 2 different formulas. You will be given these on the test. You do not need to memorize them because I know that's what you're going to ask. This is the first one. You'll notice the summation notation on the left-hand side, and that is explained by the formula on the right. Okay, the formula on the right-hand side of the equal sign is what you need to know. Okay, a lot of these terms should look familiar, except for one of them is new. Okay, the k value in your formula is the value of the term you're trying to find the sum of. Okay, so that would be that red term on the top of your sigma that you've seen in the summation notations from previous slides. Okay, so whatever term you're trying to get to or trying to add up to, that's what the k value is going to be. You can see the u sub 1 is the first term, the d there is the common difference, and the 2 is going to be a constant along with the minus 1 that's also part of the formula. Those won't ever change as far as the minus 1 and the 2 go. All you have to do is put the values into where they belong in the formula and solve. Now, one of the key things of doing these formulas is you have to try them. Okay, these formulas can be somewhat tricky. It is a skill to put these formulas in a calculator correctly and get the right answer. Okay, if you're not doing this right, then you're going to get it. You're not putting it into the calculator correctly, you're going to get it wrong. Okay, so here's an example. Here's our sum. It's 2, 4, 6, 8. This is an arithmetic sequence because it is going up by a common difference of 2. We want to find the 75th partial sum. So we're going to use the formula for arithmetic sequences. Okay, you should have had a chance to write that one down in the box above in your notes. And we're going to put all the values where they belong. So our k value is going to be 75. We're going to put that in 3 different spots. Your u sub 1 is 2, and your common difference is also 2. This is what it will look like. Okay. Now, I've given you the answer of 5,700. It is extremely important that you try to put this in your calculator and get that number. If you can't get 5,700 by putting all this stuff in your calculator, then you need to get some help on how to use your calculator correctly and punch in the values. Okay? If you're getting 5,700 and you have no problems, well then great. Awesome. You're doing great and you're on the right track. Okay? So again, it is very important that you try this on the calculator to see if you're getting the correct answer. Okay. Oftentimes in past years when you're in class, I'd be able to help you. Hey, this is where you're making a mistake. It's a little bit hard to do now because this is a video. All right. The other part of this is the geometric partial sum. Okay. Again, you'll see the summation notation on the left. You don't really need that. It's just to show you that this is a partial sum. Okay. And the formula, again, has some common pieces in it that you've seen before. The u sub 1 is the first term of your sequence. The r stands for common ratio. Right? And you only have one k in this case, and the k, again, is the final value you were trying to find. Okay, that ends your sequence. And you have a chance to write this down again at the top of your, in the box above, the problem that we're doing next, which is this. Okay, so now we have 2, 4, 8, 16. Again, this is a geometric pattern. It has a common ratio of 2. We're multiplying by 2 each time. We're going to find the 15th partial sum of the sequence. Okay. So if this is your formula, your u sub 1 will be 2. The 1s are a stock part of the formula. Your common ratio is 2. Your k value is 15. Okay. Now, one of the things that is very complicated about this formula itself is students will often do in the calculator the 1 minus rk divided by 1 minus r. That won't get you the right answer. Okay, you have to put parentheses around the top of your fraction and then parentheses around the bottom of your fraction before you divide them. Okay. Again, this is a skill to put this in the calculator. If you put it in, this is what it will look like. All right, and again, I have provided the answer to make sure you were getting this right. So again, put this in the calculator. If you are not getting the answer of 65,534, then you've entered something wrong. It's important that you get some help to fix it. Okay. If you can show me what you're doing in the Zoom meeting, then we can help you out and get you in the right place. Okay, so this is the end of the video for partial sums. There are 4 more questions. Please do those 4 questions for your CFU, and I wish you luck.